There is a moment that most people who have lost someone describe in almost exactly the same way. They wake, and for 2 or 3 seconds the world is still intact. The person is still there. Nothing has changed yet. The house still holds the shape of a life that included them. And then the brain catches up, and something collapses inside the chest, and the absence arrives as though freshly cut. This is not poetic license. It is not a metaphor for grief. It is a specific, measurable neurological event. And it has been happening to humans for as long as we have had the kind of brain capable of building a complete internal model of another person. What you experienced in that dream, seeing them alive, speaking with them, moving through a world that still contained them, was not your mind giving you a gift. It was not a visitation. It was not a form of communication from somewhere beyond what science can measure. It was a prediction error, a specific mechanistically explicable failure of the brain's updating system. And to understand why it happens, why the dead walk through your dreams as though they never left, you have to begin with what the sleeping brain is actually doing. The research on sleep and grief intersects at one of the most consequential phases of the sleep cycle, REM, rapid eye movement sleep. Dr. Robert Stickgold at Harvard Medical School, whose laboratory has produced some of the most rigorous work in the field of sleep and memory, has described REM not as passive rest, but as an active neurological workspace. In REM, the brain undergoes a set of changes that distinguish it from every other state in the 24-hour cycle. One of the most significant is a dramatic reduction in activity in the dorsolateral prefrontal cortex, the region most associated with logical sequencing, cause and effect reasoning, and what researchers call reality monitoring. Functional MRI studies measuring cerebral blood flow and metabolic activity during REM have documented this reduction consistently across multiple research groups. The prefrontal cortex does not go entirely offline, but its contribution to the regulation of experience falls to a fraction of its waking capacity. Simultaneously, the amygdala, the brain's core emotional evaluation structure, located deep in each temporal lobe, becomes more active during REM than it is during ordinary waking life. In a landmark 2002 paper, co-authored by Stickgold and Matthew Walker, then at Harvard and later directing the Center for Human Sleep Science at UC Berkeley, research from sleep laboratory studies described REM as a neurochemically unique environment in which emotional memories are processed under one specific and unusual condition: near zero levels of norepinephrine. Norepinephrine is the neurochemical most closely associated with threat response and emotional urgency. During every other phase of the day and night, it circulates at measurable levels throughout the brain. During REM, its concentration in the cortex drops to the lowest point in the entire cycle. This matters because it means the brain can reactivate intensely emotional memories during RREM, can run them through the amygdala with full intensity, while simultaneously reducing the stress signature associated with those memories. The emotional content arrives without the cortisol spike. The memory runs without the full weight of what it cost you to live through it the first time. This is where the first mechanism lives. But REM alone does not explain why the person you lost appears in your dreams alive and present and behaving exactly as they behaved in life. For that, you need to understand how the brain stores a person. If you are watching this video and you lost someone whose absence still has weight, I want to mention something before we go further. There is a short guide called What Feynman Knew About Grief. It is in the pinned comment below this video. It takes the science in this channel and moves it into the specific territory of what to do with understanding when the grief arrives anyway. It is only available while this video is up, and I want to ask you something while we are here together. When you dreamed of them, did you know inside the dream that they were gone? Most people say no. That is not a failure of memory. That is exactly what the next part of this explains. Every encounter you had with someone you loved, every conversation, every morning routine, every ordinary afternoon that neither of you would have thought worth remembering, was being encoded by your hippocampus. This structure, one in each hemisphere, curved along the inner surface of the temporal lobe, is the brain's primary recorder of episodic memory. The autobiographical record of what happened, when, with whom. But the hippocampus is not a permanent archive. It is a staging area. The memories it records are temporarily held there and then, through a process that happens primarily during sleep, transferred to the cortex, the vast outer surface of the brain, where they become part of a distributed network. This transfer is called consolidation. It requires sleep. It requires REM, in particular for emotionally significant categories of memory. And it involves the hippocampus replaying compressed versions of stored episodes at speeds far faster than real time. While the regions of cortex that will eventually hold these memories are updated, electrode recordings in sleeping humans and in animal models, conducted at laboratories, including the Wilson Lab at MIT and the Buzzacchi Lab at New York University, have captured this hippocampal replay directly. Sequences of neural firing corresponding to patterns active during waking experiences replayed rapidly during sleep. What this means is that the person you loved, after years of shared life, is not stored in one place in your brain. They are encoded across hundreds of thousands of synaptic connections distributed throughout your cortex. The timbre of their voice corresponds to patterns in the auditory association cortex. The geometry of their face is held in the fusiform gyrus and surrounding regions of visual cortex in patterns so refined they can be triggered by an angle of light that resembles them, the way they move before speaking, the particular quality of their attention, the specific weight of their presence in a room. Each of these corresponds to a distributed pattern across your cortical surface. Together, these patterns constitute what computational neuroscientists call a predictive model. A model that, once built, runs continuously, not as a choice, as infrastructure. Here is where the science becomes most directly relevant to the experience of grief. Carl Friston at University College London has developed what is now called the predictive processing framework, arguably the most influential theoretical account of brain function to emerge in the last 2 decades. Its central claim is that the brain is not primarily a receiver of reality. It is a prediction engine. Your brain does not wait passively for sensory input and then interpret what arrives. It generates predictions in advance, constantly, about what you will see and hear and feel in the next moment. When incoming sensory data matches the prediction, the brain registers nothing and updates silently. When incoming sensory data fails to match the prediction, when reality diverges from the model, the brain flags this as a prediction error and generates a corrective signal. This process runs at every level of perception, from the firing of individual neurons in visual cortex to the complex anticipation of another person's behavior in a shared room. The person you loved was embedded in thousands of your brain's predictions every single day, not consciously, automatically. When you moved through shared spaces, your predictive system ran simulations of a world that included them. When you heard a sound from another room, your brain briefly mapped it against the catalogue of sounds associated with their presence. When you reached a particular time of day that had always included them, your predictive machinery began anticipating their presence before any sensory data could confirm or deny it. These predictions were not thoughts. They were learned patterns, accumulated over years, woven into the infrastructure of how your brain navigated the world. And when they died, the only thing that changed immediately was the sensory input. The model kept running. What Feynman knew about grief is in the pinned comment below. The full explanation, the science behind why the model keeps running even when understanding arrives, is there. It is only available while this video is up. The link is in the pinned comment. During waking life, a mechanism called reality monitoring, mediated primarily by the prefrontal cortex, catches the mismatch. The prediction fires implicitly, they might be there. Reality monitoring intercepts, they are not. The update registers, and grief arrives in the gap between prediction and correction. During REM sleep, the prefrontal cortex is not performing this function at anywhere near full capacity. The predictive model of the person you loved is still in the cortex. The hippocampus is replaying episodes involving them, because those episodes were among the most emotionally significant, and the amygdala, fully active during REM, tags emotionally significant material for priority processing. The simulation runs without the corrective mechanism, and so they appear in your dream alive, not because the dream is delivering information, because the brain is running a model it has not yet received permission to revise. This is the mechanism, not mystery. Mechanism. Dr. Joshua Black at Brock University in Canada conducted systematic research specifically on post-bereavement dreams, what the clinical literature calls dreams of the deceased. In survey data gathered from more than 300 individuals who had experienced the death of a close person, Black documented a consistent pattern. In the overwhelming majority of reports, the deceased appeared alive, not as a ghost or an apparition, not as a figure the dreamer knew to be past, as a person present, behaving in ways consistent with how they had behaved in life. Participants were not confused in the dream. They were not grieving inside it. The grief arrived on waking. And this distinction between what the dream contained and what the waking arrival of reality delivered is precisely what the predictive processing account would predict. The sleeping brain, without reality monitoring, runs the intact model. The waking brain encounters the prediction error. And because the simulation was vivid and complete, the error is enormous. Many of Black's participants described these dreams not as comforting in any simple sense, but as complicated, a word that appeared across accounts with striking regularity. The dream had felt real, the person had felt present, and so the waking was not simply the continuation of grief, it was a new instance of loss, arriving from within sleep itself. Others described a residue that persisted through the waking hours. Not warmth, not peace, but something harder to name. A proximity, a sense that the architecture of the world had briefly re-included someone, and had not yet fully expelled them again. Why some people dream of the dead frequently, and others rarely or never, is not yet resolved with the precision that would satisfy clinical standards. What is mechanistically plausible, based on what we understand about consolidation and emotional memory processing, is that the frequency of these dreams correlates with how deeply embedded the person's predictive model was in the dreamer's cortical network, and how many emotionally significant episodes are still awaiting consolidation in the period following the death. The hippocampus does not process its entire backlog at once. In the months after a significant loss, the replay continues. The appearances continue. The prediction error arrives each morning, again as each night gives the model another uninterrupted run. If anything in this science has landed with weight, the idea that the brain keeps running a model the world no longer confirms. The guide in the pinned comment below goes further. It is called What Feynman Knew About Grief. It is available only while this video is up. Dr. Mary Frances O'Connor at the University of Arizona, whose neuroimaging work on grief has used both functional MRI and positron emission tomography to examine what the grieving brain actually does when confronted with reminders of the deceased, published findings in 2008 in the American Journal of Psychiatry that revealed something no one had fully anticipated in individuals experiencing what clinicians classify as complicated or prolonged grief. Grief that has remained intense and disruptive well past the period typically observed. Viewing photographs of the deceased activated not only the regions associated with pain and sadness, but a structure called the nucleus accumbens. The nucleus accumbens is the brain's primary dopaminergic reward hub. It fires in anticipation of reward. It activates when the brain expects something it wants to receive. In participants not experiencing complicated grief, this activation was absent. In those still caught inside their loss long after the death, it was present. The system was still reaching, still generating the neurochemistry of anticipation, still expecting the prediction to resolve into the presence it was built to receive. O'Connor's interpretation was appropriately cautious. This finding was mechanistically suggestive, not definitively explained, but what it suggests is this. For certain brains, the predictive model of the person who died had not been reclassified as permanently absent. It was still being treated at the level of reward circuitry as a source of anticipated input. The prediction had not been corrected. The nucleus accumbens was waiting for a confirmation that the sensory environment would never deliver. The evolutionary framework makes this legible. For the overwhelming majority of human history, across the hundreds of thousands of years during which the modern human brain was shaped by selection, the predictive models the brain built for the people it loved were built in a world where absence resolved. The person left and came back. The person slept and woke. The person went beyond the edge of what could be seen and returned. The brain calibrated itself against an enormous data set in which temporary absence was the dominant pattern and permanent irrevocable absence was the rarest outcome within a social group. The predictive machinery was built around return. It knows how to register a prediction error of temporary absence and hold the model in readiness. What it does not have, what no configuration of the human brain has ever been required to develop, is a clean and rapid mechanism for reclassifying a person as permanently removed from the prediction. The prediction error accumulates, the model holds, and in sleep, where the only corrective system goes offline, the model runs without any interruption at all. They appear in your dreams alive because that is what the brain built, not a memory of them, not a reconstruction of them, a running model, one that continues generating predictions, continues reaching into the sensory environment for confirmation, continues expecting what it was built to expect. The dream does not create this model. The dream simply gives it space to run, without the prefrontal cortex arriving to say, "Stop, check the incoming data." The data is not what the model predicts. In the 2 or 3 seconds after waking, in the window before the prefrontal cortex has fully re-engaged its monitoring function, the prediction has not yet failed. The model is still running the version of the world that includes them. Reality monitoring returns gradually, not instantaneously. And in that gradual return, in that space measured in seconds where the brain has not yet corrected itself, you carry the intact version of the world for a moment longer than you can bear. And then it corrects. The error registers. The absence arrives. Not once. Across every dream that ends. Across every waking that delivers the prediction error freshly. As though the nervous system has no record of having survived it before. Because in some sense, the part of the brain responsible for that correction, the prefrontal cortex, returning to full function, did not experience what happened in the dream. It was offline. And so every correction is new. The brain does not grieve by choosing to. It grieves because it built something, and what it built is still there, still running, still reaching into a world that no longer confirms it. The model keeps predicting. The silence keeps answering. And in the dark of every night that follows, the sleeping brain goes back to what it knows, back to the version of the world it spent years constructing, and runs it again, uninterrupted, with the fidelity of something that does not know how to stop being accurate about what it loved. The What Feynman Knew About Grief guide is in the pinned comment below. It is only available while this video is up.